So the first lesson was about relations and functions. This lesson is going to be about linear relation. Okay, has the term would mean if I see that term linear, that means line. So what we're going to have here is a graph of a line. Okay, so the graph of a line. So I have x plus y is equal to 5. Here's the graph of that, and that is a line. Every point that's going to be a solution to this particular equation is going to be on that line. Now, if it's a linear equation, here are the rules. There's no operations other than addition, subtraction, multiplication of a variable by a constant. All right, so it can only add, subtract, or multiply. When we talk about multiply, we're talking about division because I can take x divided by 2, which is 1/2 times x. So think of division that way too. Variables are not multiplied together. Variables are not in the denominator or downstairs in the fraction, and variables are not raised to a power other than the power of 1. The graph of a linear equation is going to be on a line, which we discussed already. So here's some examples of linear equations. Y is equal to 2x, 2y plus 5x is equal to -8, y is equal to 3, x is equal to -1/2, y is equal to 3 fourths, x plus 2/3. Those are all examples of linear equations. This is not a linear equation. Why? I have a square. This is not. Why? Because I have x times y. This is not because I have the square root. This is not because the variable is in the denominator. A linear function, then, is a function with ordered pairs that satisfy a linear equation. All right? This would be an example of a linear function. Now, remember we talked about the vertical line rule. If I were to draw a vertical line, no matter where I drew it, that vertical line is only going to go through one point. So this is a function right here. This equation x plus y is equal to 5 is a function. Now, in general, it's usually written as f of x or y. Remember that f of x is equal to y is equal to mx plus b, where m and b are real numbers. All right, and we'll discuss this later as we move on, but this is kind of one form we're going to write about. In general, we want to leave it in that form. Okay, state whether it's a linear function. Okay, yes. Y is equal to 3x, that's fine. Y is equal to -2 plus 5x, that's fine. 2x plus y is equal to 10, that's okay. F of x is equal to 4x squared. Think of this as y is equal to 4x squared. We know it's not going to be because of the x squared, however. -3 over x plus y is equal to 15. X is in the denominator. No. X is equal to y plus 8. That's fine. G of x, y is equal to 8. We could do that. H of x, y is equal to the square root of x plus 3. Well, we have the square root sign here, so this would be no. So this one, and this would not be linear functions. Okay? The standard form of linear equation is going to be ax plus by is equal to c. A is the number in front of x, b is the number in front of y, and c is the number by itself. Where a, b, and c are all going to be integers. They have to be integers to be in standard form. The greatest common factor can only be 1, okay? And I'll go over that in a second here. And a, this number right here in front of the x has to be greater than 0. And a and b are both not 0. If I did, would make 0 is equal to 0 what I end up with, so that doesn't make a whole lot of sense. Okay, so is this, to get this in standard form, I got to get that 5x has to be positive, the y has to be on the same side as the equation of the x, and the constant or the number by itself has to be on the other side of the equation. So this is already in standard form. This is okay. If I have 0 is equal to 3y minus 2x minus 8, well, the x has to be positive, so let's add 2x to both sides. And that gives me 2x is equal to 3y minus 8. Well, to get the y in the same side of the x, I'm going to have to subtract 3y here, subtract 3y here. And when I do that, I'm going to end up with 2x is minus 3y is equal to a -8. So now that is in standard form. All right? Just to go over one I talked about earlier. If I have 2x plus 4y is minus 6 is equal to 0. There is a common factor here. That common factor is going to be 2. So let's take that 2 out. And I count x plus 2y minus 3 is equal to 0. Let's divide both sides of the equation by 2. Those go away. 0 divided by 2 is going to be 0, so I get x plus 2y is equal to 0. Now to put this in in standard form, I need to subtract 3 from both sides. Pardon me, not subtract 3. I should have a 3 here, shouldn't I? I have to add 3 to both sides. And when I do that, I get x plus 2y is equal to a 3. Now this is in standard form. Okay, so 4y is equal to 8 minus 6x. Common factor here is going to be 2. Got to get rid of it. So I got to take a 2 out, and I take a 2 out of this, and I'm left with 2y. I take a 2 out of this over here. I come up with 2 times 4 minus 3x. Let's divide both sides by 2. Those 2's go away here. Those 2's go away here. I'm left with 2y is equal to 4 minus 3x. Now I have to add that 3x to the other side. And when I do that, I get 3x plus 2y equal to 4. We won't worry about this one right now, but this is an idea of what we have to do to get this into standard form. Okay, when I have a graph and I have a line, and this is an example, this graph is going to cross the x-axis at this point. That point right there is referred to as the x-intercept. It's where the graph crosses the x-axis. Notice that the x value, I'm going to say, is going to be x, but my y value is going to be 0. Okay? The y-intercept is where it crosses the y-axis. Here's the y-intercept. All right? In this case, my x value is 0, and I'm going to come up with some value for y. Okay. Now, if I'm given 2 points, if I can find out the x and the y-intercept, I can graph this because, remember in geometry, through any 2 points there is only one line. So if I find these 2 points and I draw that line, that's going to be the graph of the line I am looking for. So I want to write 2x plus 6 is equal to 3y in standard form, find the x and y-intercepts, and then graph. All right. Well, if I have 2x plus 6 is equal to 3y, the x is positive. So on one side of the equation, I need to get the 3y over there. So let's subtract 3y. And then I'm left with 2x minus 3y plus 6 is equal to 0. Now I have to get the 6 to the other side, so I'm going to subtract 6. So I get 2x minus 3y is equal to a negative 6. All right, so this is an example. Now I've got it in standard form. So let's get rid of all of this. All right, and before I do that, let's move this up here. Okay, so that's my equation in standard form. Now, I want to find the x and the y-intercept. Okay, well, here I'm going to put values in for x and values in for y. All right, so when x is 0, what does y have to be to equal negative 2? Well, it's going to have to be, and let's change this graph a little bit here. And let's go back here and let's make this 2x minus 3y is equal to a negative 6, and then I'm going to come up with negative 6, and then I come up with a value for y. So when x is equal to 0, I'm going to get 0 minus 3y is equal to a negative 6. And if I divide both sides by 3, I come up with y is equal, negative 3. I come up with y is equal to 2. Okay, so my y value when x is equal to 0 is 2. So when x is equal to 0, y is equal to 2. Now, let's make my y value equal to 0 and find out what my x value is going to be. In that case, it's going to be 2x minus 3 times 0 is equal to a negative 6. Well, that's a 0. So what do I have to multiply 2x by to get to be a negative 6? I have to multiply this by a negative 3. So when x is equal to a negative 3, y is equal to 0. All right? There's the equation. There's my 2 points, I should say. And so there becomes the equation of my line. All right. So that's the idea of linear relationships, linear equations. We will continue to discuss these as time goes on and become more in depth of what a linear equation is, what a linear function is. All right. Any questions? Keep those in mind. We will talk about those tomorrow.